In this video, we will be reviewing some right triangle trigonometry. By the way, did you know that the word trigonometry means three-sided measurement, which is really just the measurement of triangles. Okay, so if we have a right triangle, that means that one angle is 90 degrees. And we would label the legs A and B and the hypotenuse C. And then the Pythagorean theorem says that A squared plus B squared equals C squared. There are special right triangles that come up a lot in problem solving. 45, 45, 90, which is also an isosceles right triangle that has two sides the same length. That's this one over here. There's an isosceles right triangle. And a 30, 60, 90 right triangle, which is this one here. These special right triangles you don't need to know, but they're nice to know. With special right triangles, we can label the legs and the hypotenuse. And for a isosceles right triangle, or a 45, 45, 90, we know that the hypotenuse equals the leg times the square root of 2. We can also write that as the leg equals the hypotenuse divided by the square root of 2. For a 30, 60, 90, which is this yellow triangle here, the hypotenuse, which is the longest side, is equal to the short leg times 2, and the long leg, notice the short leg is across from the shortest or the smallest angle, and the long leg is across from the 60-degree angle. The long leg equals the short leg times the square root of 3. So that's we can use that to find missing lengths in a right triangle, in different kinds of right triangles. The other thing that we can use to solve right triangles are the trig ratios. So for the trig ratios, I would draw a right triangle, or I would be given a right triangle. I would mark and measure an angle, and then I would label the sides. So this is the hypotenuse, this is the opposite side, this is the adjacent side to the angle. The opposite side is always across from the angle, and the hypotenuse is always the longest side. Then the trig ratios are as follows. The sine is opposite over hypotenuse. The cosine is adjacent over hypotenuse, and the tangent is opposite over adjacent. So now let's apply some of these formulas to this mixed review. Here's a problem where we're missing a side length of a right triangle. The legs, I could label A and B, and it doesn't matter which order I do that in. And C is the hypotenuse. The Pythagorean theorem says that A squared plus B squared equals C squared. So 18 squared plus X squared equals 25 squared. So 18 squared is 324 plus X squared equals 25 squared is 625. Then I would subtract 324 from both sides. I get X squared equals 301. And finally, I would take the square root of both of those numbers. So the square root of 301 is 17.3. So that is my missing side, or the hypotenuse. Oh, I switched from C to X. That was sloppy. Let's keep calling it C just to be consistent. C is 17.3. Okay. In question 2, I am given an angle and I'm missing a side. And in a question like this, I'm going to use either sine, cosine, or tangent. So my first step would be to mark the angle and then label the sides. The sides are opposite leg, adjacent leg, and hypotenuse. The hypotenuse is always across from the right angle. It's the longest side. So there's my hypotenuse. And that's actually not labeled, so I'm not going to use it in this question. The opposite side or opposite leg is across from the angle, and the adjacent side is next to the angle. And let's look what I have here. I've got adjacent and opposite. So, oh my goodness, I wrote this wrong. So if I've got adjacent and opposite, I am going to use the tangent because the tangent ratio, the tangent of the angle is the opposite side over the adjacent side. So I'm going to write down my formula. And again, I'm choosing tangent based on opposite and adjacent. So the tangent of the angle equals opposite over adjacent. Tangent of 39 equals 52 over x. Now I need a calculator. I'm going to make sure that my calculator is in degrees mode. And I'm going to type in the tangent of 39. I'll actually switch over to Desmos. So I would type in the tangent of 39. And notice here that I am in degree mode. That DEG means I'm measuring in degrees. So 0.8097, I'll round it to 0.81. So I have 0.81 equals 52 over x. Now to solve this with x in the denominator, I'm going to multiply both sides by x. And I get 0.81x equals 52. And then I'm going to divide both sides by 0.81. So x is going to equal 52 divided by 0.81. And I get 64.2. I have another calculator here that allows me to do this a little bit faster. Okay? Okay, let's look at another one. Solve the right triangle, meaning find all the side lengths and angle measures, round to the nearest tenth. All right, let's look at this one. Look at this. Angle A is not listed, but we know that the sum of angles in a triangle is 180. So to figure out angle A, I could take 180 minus 90 minus 53. And when I do that, I get 37 degrees. So there's angle A. Okay, now I've got two missing sides. And I'm going to go back to what I was originally given. I'm going to mark my angle. I'll mark angle B. I'm going to label the sides. Hypotenuse is always the longest. Opposite side is always across from the marked angle. And the adjacent side is next to the angle. And let's say that I want to find the adjacent side first. Do I use sine, cosine, or tangent? Well, I've got adjacent and hypotenuse. Adjacent and hypotenuse. So I'm going to use cosine. So I'm going to say the cosine of the angle is equal to adjacent over hypotenuse. So the cosine of 53 equals adjacent over 5. So now again, I need my calculator. So I'll go the cosine 53, 0.6018. Now with this one, I simply multiply both sides by 5 to solve for the adjacent. So now I'm doing 0.6 times 5, which gives me 3. This adjacent side then is 3, and that is BC. Now to find AC, I have two choices. I could do another sine, cosine, or tangent, or I could use the Pythagorean theorem if I wanted to. Because I could say I have A when I solve this, I get B squared equals 16, so B equals 4. So I could solve it that way, or I could have used sine or cosine to solve it. That's called solving a right triangle. And it's really just, for our purposes for physics, we're just practicing so that when we see a right triangle in physics, we know how to approach it. Here's a little review question from geometry or advanced algebra or algebra 2. Is this an isosceles right triangle or a 30, 60, 90? Well, we've got one 90-degree angle here, and we know that the other two angles have to add up to 90, and they're the same because these two sides are the same. So this is an isosceles right triangle. I could find x in two different ways. One way I could do it is to label the legs and the hypotenuse and then go back to my formulas. Here we see that the hypotenuse equals the leg times the square root of 2 for a 45, 45, 90. So that formula is really just a shortcut. Hypotenuse equals leg times the square root of 2, 7 times the square root of 2. What if I didn't remember that formula? I could go back to the Pythagorean theorem. I've got my legs, 7. Now it turns out that the square root of 98 is the same thing as 7 times the square root of 2, and here's why. It's equal to 49 times 2, or the square root of 49 times the square root of 2, which is 7 times the square root of 2. If you really hate that, in physics, you can always give your answer as a decimal. 7 times the square root of 2 is equal to 7 times 1.414. So 7 times 1.414 is 9.898. And if I do the square root of 98, just to check that this comes out the same, in my calculator, the square root of 98 is 9.89. So the answer comes out the same whether we use the formula for an isosceles right triangle or go back to the Pythagorean theorem, or there are other methods too with SOHCAHTOA, but I'll stop there. Let's do one more sample problem. Is this an isosceles right triangle or a 30, 60, 90? Well, I can see a 60-degree angle and I can see a right angle. That one's 90. So the other angle must be 30. So this is a 30, 60, 90 right triangle. And we're supposed to find the values of x and y. If I go back to my picture from up here, I have, actually, I'll do this. It's nice to be able to see the formula at the same time. So I'm going to label this. We've got a short leg. We've got a long leg. And we've got a hypotenuse. Now we're given the long leg here. The long leg is our given number. So let's look at this formula. The long leg equals the short leg times the square root of 3. Long leg equals short leg times the square root of 3. That means that if I were to divide both sides by the square root of 3, it means that the short leg equals the long leg divided by the square root of 3. So on this picture, the short leg would equal 7. Seven is my short leg divided by the square root of 3. And then it says that the hypotenuse is equal to the short leg times 2. Well, I have the short leg. It's 7 over the square root of 3 times 2. So the hypotenuse would be 14 over the square root of 3. 7 times 2 is 14. In physics, we're not quite as fussy as we are in math. In math, they don't like having a radical in the denominator, but in physics, we can roll with it. Okay, thanks for listening, and good luck.